So the first thing we have to know about scientific notation is the concept of place value. So remember, we have the ones, we have the tens, and we have the hundreds. And we could go beyond that to bigger and smaller place values. Now, one thing that's important is that every place value is 10 times bigger than the ones before it. For example, a 10, which looks like this, is 10 times bigger than a 1. In other words, it takes 10 of these 1s to make one of these 10s. And the same thing could be said for a 10 to 100. It takes 10 of these 10s to make one of these hundreds, and it takes 10 of these hundreds to make one entire 1,000. That concept of place value is really important. Now, every time we go up 2 place values, it takes 10 of these to make one of these, so 10 ones to make a 10, and then it takes 10 tens to make 100. So each time we move up 2 place values, it's like doing 10 times 10, which would be 100. So it would take 100 of these to make one entire 100. That concept of place value is going to be really super important when it comes to scientific notation. So let's take a quick look at what we were just talking about with pictures, and let's see what that looks like in numbers. So remember that every place value is 10 times bigger than the ones before it. So a 10 is 10 times bigger than a 1. The same thing can be said for 100 to a 10. So 100 is 10 times bigger than a 10, and a 1,000 is 10 times bigger than a 100. Now, every time we're skipping 2 place values, so if we skip 1, 2, that's the same thing as multiplying by 10 twice. So 1 times 10 is 10, times another 10 is 100. So that tells me that a 100 is 100 times bigger than a 10. So moving 2 place values is like multiplying by 10 twice. Now let's say we move instead of 2, let's say we move over 3 place values. Moving over 3 place values is like multiplying by 10 3 times, which is the same thing as saying 100 times 10, which is like multiplying by 1,000. So every time we move up another place value, we're multiplying by 10 one additional time. So, since we're talking about this concept of place value and this concept of place values being 10 and 100 and 1,000 times bigger than others, and always focusing on that concept of 10, let's think about also the concept of exponents. So for example, when we're writing the number 10, another way to write the number 10 would be 10 to the first power. Remember, the 10 to the first power is the same as just 10. Another way to write the number 100 would be 10 to the second power, because 100 is the same thing as 10 times 10. And another way to write the number 1,000 would be 10 to the third power, which is 10 times 10 times 10. This concept of exponents is also going to be important as we start to think about how we're going to write numbers in scientific notation. So next we're going to take a look at an actual number that we're going to try to write in scientific notation. Let's start by looking at a big number, and that big number we're going to look at right now is the number 4 million. Now, when we're thinking about writing a number in scientific notation, one thing that we need to think about is the number that we're writing should be either a really big number or a really small number. Now, one thing I'm going to start off by thinking about is where would the decimal be in this number? Well, since this is a whole number, remember the decimal is going to be at the end of the number. Now, I'm going to move the decimal point back until I have a whole number between 1 and 10. And as I do it, I'm going to count how many times it takes. So it takes 1, 2, 3, 4, 5, 6 times. And if I put the decimal here, you'll notice that I have the number 4. Now, The number 4 is nowhere near as big as the number 4 million. So we got to think, how many times did I move the decimal? Well, we just counted, and we'll count again. 1, 2, 3, 4, 5, 6 times that I moved that decimal. Now, each time I moved that decimal in this direction, what I was actually doing was I was dividing that number by 10 over and over and over. So because I divided it by 10 over and over and over, I've made that number significantly smaller, dividing by 10 6 times. So what I'm going to do is I'm going to make up for that by doing the opposite, which would be multiplying by 10. So down here for my scientific notation, I am going to write 4 times, and I'm going to think, how many times did I multiply by 10? Well, I multiplied by 10 6 times. Now remember, 10 to the 6th is the same thing as saying 10 times 10 times 10 times 10 times 10 times 10, which is the same as a million. So basically what you're saying here is you're actually saying 4 times a million, which is 4 million. Let's look at one more example. So this time we're going to look at a slightly bigger number, and one thing you'll notice this time is it has more than one digit that is not 0. So you'll notice I have a 6 here in the billions place, and I have a 2 here in the 100 millions place. So this one's going to be slightly different, but the same concept. Now, same thing as we did before, I'm going to put my decimal at the end, because remember we're looking at a whole number in 6,200,000,000. So I'm going to count out loud again, how many times did I move the decimal back? Now remember, we want a number between 1 and 10. So I'm going to move it back 1, 2, 3, 4, 5, 6, 7, 8. If I stop here at 8, notice I have the number 62. That number is not between 1 and 10, so I'm going to move it back one more time, which would be 9 times. Now, the number that I have that is between 1 and 10 is 6 and 2 tenths. Now, like I said before, when we're moving the decimal in this direction, that's the same thing as dividing by 10 each time we're moving that decimal over. We want to make up for that, so starting at 6 and 2 tenths, we are going to multiply that number by 10, and thinking about how many times we're going to multiply it, we'll think, how many times did we move the decimal over? We divided by 10 9 times, so to make up for that, we're going to multiply by 10 9 times. And if you're wondering, well, what if I started out with this scientific notation? You can easily change that back to the original number that we started with. So an easy way to do that would be to say, well, I could start out with 6 and 2 tenths. And since we're multiplying, I know that I am going to move the decimal in this direction because my number is getting bigger. And how many times am I going to move it? I'm going to move it 9 times because we're multiplying by 10 9 times. So I am going to move this decimal over 1, 2, 3, 4, 5, 6, 7, 8, 9. And in all those empty places, we're going to put those zeros that we had in the number before. So 0, 0, 0, 0, 0, 0, 0, 0. Remember, the decimal is now at the end, so I can actually remove this decimal here in the beginning, and I have that original number that I started with. So that's a really easy way to move back to the original number that we started with. Now to finish, let's look at one example where we're actually taking a really small number, such as this, and we're also writing it in scientific notation. Now this is basically just backwards of what we were doing before. We're still locating the decimal, which notice the decimal in this number is right here. We already see that decimal because it's not a whole number. Now we're going to move this decimal, but this time we're going to move it to the right because we're trying to get a number between 1 and 10. Remember that when you're moving that decimal to the right, each time you do that, you're multiplying by 10. So we're multiplying by 10 each time. So I'm going to move that decimal over 1, 2, 3, 4, 5, and I'm going to put it right here. Notice that when I do that, I have arrived at the whole number 2. Now this time we've done the exact opposite of what we did last time. We multiplied this number 1, 2, 3, 4, 5 times by 10. So to make up for that, we need to divide by 10 5 times. Now, scientific notation always has a symbol that is multiplication. So we have to think, how can we show dividing by 10 5 times? Well, when we're working with exponents, one way to show that is instead of using a positive exponent, we can use a negative exponent. 10 to the negative fifth is the same thing as dividing by 10 5 times. So in order to write a really small number in scientific notation, you're always going to notice a negative exponent right here. So this number would be written 2 times 10 to the negative fifth. Now, if you want to practice a couple numbers on your own, I encourage you to try to take these two numbers and see if you can write them in scientific notation. Remember that this top number, 650 million, is going to have a positive exponent because you're multiplying by 10 over and over. And this bottom number, since it's really small, is going to have a negative exponent since you're moving the decimal in the opposite direction and you're going to be dividing by 10 over and over. Give those both a try and see how it works for you.